So, where do we start? What is the first step to determining the carrying capacity of the Earth? Well, this is where a systems approach comes in. A logical start would be with a full survey of the Earth's resources, since we must know what we have to work with in order to arrive at any decisions. There are many natural resources to be considered, such as forests and oceans and energy, along with arable land, water, and minerals. But for the sake of simplicity, let us refer to these components as natural resources. If anyone is currently thinking, well, this makes sense, but how would it even be possible to create this kind of a global system? Or perhaps you might be thinking that the technological know-how for such a comprehensive survey is a bit too futuristic. Well, at this point, I'd like to make use of a few visual examples of current real-world technical systems that are working in this regard right now. This is an accurate visualization of many current and former NASA Earth observing satellites, with names like TRIM, Landsat 7, Terra, EO1, Jason 2, Grace, IceSat, and Aquarius. These unmanned probes are quietly beaming down information that has transformed our understanding of how the Earth works and what we know of the human fingerprint on our climate. Together, they represent an application of technology in real time, working as part of a global surveying system. Not something from Star Trek, not something 100 years away, but orbiting the planet right now. Let's look at a closer example. The satellite Aquarius is designed to take comprehensive salinity measurements of the Earth's oceans in their entirety every week. The data obtained from these measurements help answer some of our most pressing questions about climate change. Why salinity? Well, the density of the ocean water is determined from its salinity and from its temperature. Density of ocean water drives the patterns of deep ocean currents, and ocean currents drive global change. In recent decades, scientists have seen that our ocean salinity has shifted in ways which only climate change seems to be able to explain. From 400 miles above the surface of the Earth, Aquarius can detect differences in ocean salinity to within a pinch of salt in a gallon of water. With this visualization, we are witnessing an example of current technology being applied via the methods of science for environmental and ultimately social concern. The collection of all of this data can be used for understanding our environment or even predicting possible outcomes. In this example, what you're seeing was not photographed from space. Every pixel here was calculated by the GEOS 5 supercomputer. This supercomputer can accurately model and simulate the Earth's atmospheric conditions for short periods of time. In this example, this model was giving data leading up until February 2nd, 2010, and then it proceeded to predict the atmosphere's response for the next 20 days without any further input. This model simulated real-world weather events that actually took place, including snowstorms, tropical cyclones, and many other climate conditions. Continuing these examples, the Terra and Aqua satellites gather data of the Earth's surface every 2 days. This animation shows where the world's food is grown versus where the world's food is consumed. The movie starts with global croplands, then fades to the countries that produce over 80% of the world's wheat, grain, and cereal. It then overlays the world's population density, and then fades to show the countries that are projected to double and triple their populations by the year 2050. There also exists a mineral resource data system, which is a statistical survey done by the USGS. This is the United States Geological Survey. This map is a collection of reports describing mineral resources throughout the United States. The survey actually expands out for the entire globe, but this map just shows an example, serves a purpose for this presentation. This is an example of information that would be part of the so-called geodatabase, if you will, integrating the data set into a global knowledge base of our resource management system as a function of a systems approach we've been exploring. Another example of visualizing a systems approach in action is viewing compiled data from our global resource system. Here, a member of the Google Earth community assembled this image from the CIA World Factbook showing world oil consumption for the year 2007. This chart displays exploding 3D graphs in the shape of each country, showing the relationship of oil consumption between countries. Here, the United States is showing its tremendous consumption of about 21 million barrels per day, which is almost 25% of the earthly total of 82 million barrels of oil consumed worldwide. That's daily, 82 million barrels a day. So, how would you possibly interact with such a system of immense data? Well, following the evolution of text-based search engines, which we're all familiar with today, we would interact with this vast knowledge base via computer or AI assistance. An example of a computational knowledge engine that already exists is Wolfram Alpha. This engine generates output by doing computations from its own internal knowledge base instead of searching the web and returning you links. In a resource-based system that we advocate, such a concept could easily be scaled out to include the immense amount of data that is currently collected both in the public and private sectors of the world today. Along with the many free information and data products out there via the internet, one could well ponder the question that if, with a little cooperation from our technology friends, could we actually have a path laid before us to move in such a direction? Well, who knows? But maybe the world is simply waiting for enough people to want to do so. The point is, there are many real-world working examples to show how such a collaborative social system is a technical reality and not a someday phenomenon. I'm going to conclude here with this artistic representation of this system as visualized by industrial engineer and I'm going to start that again. This by industrial designer and social engineer Jacques Fresco of the Venus Project, who has spent more than 70 years of his life researching such a direction. I hope this presentation has helped you understand how a systems approach to resource management could work, how we can approach problem solving beyond the sphere of politics, how we can arrive at decisions via science rather than human opinion or a majority vote, and how current technology could be applied to make such a global resource-based system a reality. So I thank you for your time. Questions and answers are not up next. Peter Joseph is up next, but we'll hit the lights. So.
Got it.
Sure. We'll do one more presentation.
When we do a Q&A, we'll definitely have lights.
Yeah, we'll have the lights up for the Q&A.
Yeah. Excellent. Thank you, Jason. That was fantastic. I would have one addendum to that in that as he began to describe that, it seems like one would need a larger context to understand why exactly a systems approach to society would be necessary. Before I begin this presentation, I'll state that put in the context of corruption. You know, you have corruption in our economic society. People often say, oh, we have all these corrupt politicians or corrupt corporations. Corruption as a concept relationship is a concept relationship in a relationship to systems, just like a hard drive on your computer might corrupt. It means it has a particular manner of organization, both hardware and software. Something happens and it corrupts it and it doesn't work properly or not at all. In the economic model, we have corruption that says, well, if a guy pulls out a gun and robs a convenience store, he's not playing the game that we've established by our system, therefore he's corrupt. Now, the approach with the systems theory is to say, well, there isn't really a true economic model in existence on the planet today because money and everything like that is a contrivance based on, well, a traditional approach that is long outdated, as I will talk about in this presentation. So where is the real system? And the system is the planet. The system is well, in Greek, the definition of economy is management of a household. So the system is the household of the entire planet, its natural laws, its physical systems, and we can only listen and adapt to that. And what we've learned through time, fortunately, is that a systems approach is the only way to go. And that's pretty much the foundation of, you know, the social system that we advocate. We want to calculate society, not have the whims of human opinion and traditional associations dictate, which are almost notoriously wrong. Well, they are, in fact, always wrong as the knowledge continues to evolve. Anyway, I don't mean to ramble here, but I'm going to jump on a bunch of those issues as we go along. But if there's anything to make clear off the top of my head, it's that the current economic model we have today, which I'm, again, going to talk about, is a corruption. Its very foundation is corrupt. Its structure is corrupt. Every attribute of it that orients from it, that blossoms out of it, is just an extension of that corruption. And the government politicians and all of the things that we talk and harp about, we see on the front page of newspapers, are only extensions of that corruption. It's a corrupt economic system because it's not actually related to planetary resources and the physical natural laws that govern our lives. So, if I haven't annoyed you already, I've divided this presentation into 3 sections. The first section is called the organism of knowledge. And this is basically how our culture evolves and tends to digest and filter information, based on biases and a few things I've already mentioned. In the second section, system consequences. As I've already alluded to, we live in a system. We organize systems around us. And I'm going to take some of the most commonly cited concerns within our current model and expand on those to express an underlying structural source, which is also an underlying structural psychology that unfortunately many do not recognize. Specifically, how most of the major problems in the world today are actually coming from this flawed economic foundation, and hence the behaviors of us that it continues to reward and reinforce that are actually detrimental. And then in section 3, I'm going to briefly discuss a new train of thought, which builds into what Jason was just speaking of, which is a ground-up logic